In the last video, or the last but one video, we have seen how to tackle a situation where we have got two factors. And the setup that we took as an example consisted of plots, where some of the plots were on the plain land and some were on the sloping ground. So we had got three varieties and two tilts. These were the two factors. And the first step that we did in order to analyze this was to make the so-called interaction plot, where we took each possible cell, that is each possible input combination, variety tilt combination. There are 6 of them, 3 varieties and 2 tilts, and for each such cell we took the average yield and plotted it. So in this case, for example, this red line stands for the yield or the variety, the first variety. So, and this was tilt is plain, so this red dot stands for the mean or the height of this red dot. This is the average yield scale, average yield axis. Height of this red dot was the average yield for all the plots that had variety 1 and tilt equal to plain. Similarly, variety 1, tilt equal to slope, and then we added this up just for visual clarity, and we similarly created the profiles, or as R calls them, traces, and we found that these were parallel. We found that they were parallel for that data set. Once we saw that these are parallel, that naturally interpreted itself in terms of this mathematical model where Yijk, that is the yield from the kth plot under the jth tilt and ith fertilizer, ith variety, that is mu plus alpha I plus beta j plus of course epsilon ijk, the Gauss Markov setup. So this thing that I have got alpha I plus beta j, just the sum of the two input effects, that is why it is called an additive model. The two effects are added up, so we could use this model. Now of course there is no guarantee. Why? We should always have an interaction plot which consists of just some parallel lines. They may very well be non-parallel. For example, they might very well be something like this. They are not parallel. Now the important thing here is not that two of these profiles intersect. That is not important. The important thing is that they are non-parallel. For example, even if my green line here that we can see is shifted up here, then they will not intersect. But still, they are non-parallel. And it is also not important that all the profiles, that all possible pairs of profiles are non-parallel between themselves. For example, here this blue profile and the red profile, they are of course parallel. That is not a point. At least one pair exists which is non-parallel. If that is the case, then of course we cannot have this model. If we have this alpha I plus beta j thing, then they are bound to produce parallel profile on an average because we have the epsilon ijk terms. So in this case, in order to accommodate this non-parallel thing, naturally we have to extend the model a little bit, and the way to do it is to add what is called an interaction term, gamma ij. Now this situation is called interaction because now we can see that the tilts will influence different varieties in different ways. For some of them we can see, for example, for the red variety, I can see that the yield goes down if you move from plain to slope. On the other hand, for this green variety, the yield actually goes up when you go into slope. So slopey land is better for variety 2, whereas it is worse for variety 1. So we cannot answer a question like, is slope good or bad? It depends on what variety you are talking about. That is exactly the idea behind interaction. And that is why this extra term that we put here is called the interaction term. It takes both I and j simultaneously into account. Now, as you can guess, even for the additive model, the no interaction model, you saw that this is over parameterized. You need less number of parameters here. Because in this case, how many things are free really? It is 6 points. They are only free. And how many do you have here? 1, then 3 alphas, 2 betas, and these 6 comma ij's. They're heavily over parameterized. So why not use something simpler like this? I can use just yij k equal to mu ij plus epsilon ij. In that case, the mu ij's are basically the expected height of each of the points. For example, this will be mu 1, 1. This is mu 1, 1. This will be mu 2, 1. The height, the expected height, of course, because of randomness, it will go up and down. Similarly, this will be mu 3, 1, mu 3, 2, and similarly for the others. In this case, I have only 6 parameters. All of them are estimable, very simply. Just the corresponding average is an estimate, and in fact you can check that it is the blue also. Also, all of them have simple interpretation. So mu 1, 1 means this, but gamma 1, 1, that is somewhat difficult to interpret. How do I interpret? If you take out the mean effect, then take out the effect of the variety, and you take out the effect of the tilt, then whatever remains, that is called gamma ij. That's not a very easy interpretation. And indeed, this model is used, and quite naturally it is called the cell means model, because for every cell, that is every combination of the input factors, there are 6 cells in this case, variety comma tilt pair, we are just having the means. We are using the mean of that as our parameter. That is the cell means model, easy to interpret, less number of parameters, everything estimable. Seems that we just have all the things going for this model. Yet, most of the time, people will use this model. Why do they do that?